Welcome to Pre-Cal. This is going to cover section 5.5, the law of sines. We are going to look at triangles, but in this case we're looking at a couple of triangles that are not right triangles, and up until this point we really haven't discovered how to work with non-right triangles. In the past we've had angles, we've had sides missing, but we've always used sine, cosine, and tangent to find those missing parts. But that was always given that I had a right triangle to start with. I don't have that now. And so we will look at the law of sines in this particular situation. Let me define the triangle. Capital letters always represent your angles. Your sides are always going to be represented by lowercase letters. The law of sines is exactly this. Sine A over A equals sine B over B, and sine C over C. Now, don't get confused. We don't always set all three parts in an equation. This just means that I can choose any angle and its match and set that equal to any other angle and its side. And so it's just a basic ratio. We're going to have two, or if you will have three of the four parts, then you'll see an example in just a minute. As long as you have three of the four pieces, we'll just basically solve for the missing variable, or solve for the missing angle, depending on which one it is, and work it out that way. So let's look at an example. So we have a triangle like that. We'll go ahead and fill in a few things about this triangle. With ABC, we have side length C, we have angle B, we have angle C, but we have nothing else. And generally the instructions for this type of stuff says solve the triangle. When you're looking to solve a triangle, you're looking to find all of its missing parts. So in this case I need to find little a, side length A, I need to find side length B, and I need to find angle A. Let's go ahead and start with what's the easiest. If at any point in time you need to pause this because I'm going too fast, please feel free to pause and let people catch up, and we'll continue on whenever you get ready. So we're going to write down all the pieces, right? And we're going to basically plug what we know into the law of sines. As long as I know these pieces, then I can set them up in the law of sines like you see here, and we will basically work them out. And this is going to end up cross multiplying, if a lot of you recognize that. We're going to solve for side length B here. B equals, basically you're going to multiply 27.4 times the sine of 102.3. We're going to divide by sine of 28.7. And that ends up being 55.5. Now, the easiest of all things to find, of course, in this case, would be angle A, because inside a triangle, every angle always adds up to 360 degrees. So be aware, if I give you two angles, the third angle is always the first and foremost easiest thing you're going to find. So don't miss those easy steps. Let's look at another example. I want you to try this one. If you need to pause and go back a little bit, you can do that if you need to go back and get the angles. So here is your information. So you have all these things. What I want you to do is you've got angle A equals 36 degrees, angle B equals 48 degrees, and we've got A equals 8. If you need to rewind a little bit and get the formula down, I want you to basically solve the triangle. Here's two angles and a side. Go for it. Pause it and come back when you're ready to go. The next part, we're going to basically solve the triangle. Oops, let me back that up. I'll work this out. Let's go ahead and draw our triangle. I find that this is usually the most valuable piece. I want to go ahead and draw what I have, label it, and fill it in. Just to, at least I'm going to be able to organize my thoughts. I'm not going to get things mixed up. So we don't have little c. we don't have little b, but we do have side length A, which is 8. We have 36 for A and 48 for B. Easy enough, we can go ahead and we can say 180 minus 36 plus 48. And that's going to give us a third angle of 96 degrees. That's a piece of cake. That's easy. You always want to see that. Now, the law of sines doesn't always have two angles. But we'll get back to what you're looking for when to use the law of sines. We're also going to study something called the law of cosines. The law of cosines, between the law of sines and the law of cosines, we'll be able to solve every non-right triangle. So let's finish this one. I'm going to go ahead and set up the law of sines to use on this particular one. It would be the sine of 36 degrees divided by 8 equals sine of 48 divided by b. Now notice I went ahead and if you know here, you got angle A and we have side length A. They match. They're both A's, capital and lowercase. And that's really your first clue of when to use law of sines. If you have a match, A and A, B and B, C and C, doesn't matter. If you have a single match, that means the law of sines is probably your best avenue. Make sure you write that down. When you have a match, I think I wrote this up later, but when you have a match, make sure that you try the law of sines. Generally, the law of sines is usually the easier one. I think most of you will agree, versus the law of cosines. So if we cross multiply, I'm not going to put all the work in there for you, but cross multiply, basically 8 times sine of 48 divided by sine of 36. If you don't believe or understand how I got here, cross multiply and solve for b, and you'll find out exactly what I got. Work this out, and we find out that b turns out to be equal to 110.115. Be careful, I am working in degrees because they gave me degrees in my problem. I think most of the time we'll be working with degrees, so be aware of that. Be looking for that. If I ended up giving you radians, then you'd have to be in radian mode in your calculator. Nothing too big to worry about, but be careful, watch for those things. B is this. If we set up the solution for finding side C, it ends up being sine of 36 over 8 equals sine of 96. I had to find that angle first before I could have done this, over C. And we find that C ends up being 13.5. Be very careful. A lot of you may have thought, well, can't you just use the Pythagorean theorem to find the third side? And the answer to that question is absolutely not. This is not a right triangle. That Pythagorean theorem only applies to right triangles, so don't get too ahead of yourself. In this case, we have actually solved the triangle. So we have side length B, side length C, and angle C. So we have 3 parts that were given to us and 3 parts that we found. Easy enough. A couple little other things we want to talk about. This is what I said earlier, so if you didn't get that down, here it is again. If you have a match, say like angle A and side length A, or angle B and side length B, or C and C, that's when you're going to want to use the law of sines. Something else that you can note is there's an alternate version of the law of sines. I don't think it's easier or more difficult. Sometimes it may feel easier if the part that you're missing is on the top of the fraction instead of the bottom. No big deal. So make sure that you set it up either A over sine A, or it could be sine A over A. You can use all the reciprocals equal to each other as well. I want to look at one more example. Remember, pause it, let everybody copy if you need more time, and just rewind. We're going to look at an example here where we have a riverbed. Inside this riverbed we have 3 points, this point, and say this point. We're going to call those just A, B, C. Real creative. What we do know is that angle A is equal to 72 degrees. Angle B equals 53 degrees. Oops. They don't tell us angle C, and they don't tell us any of the sides except angle or side length C. So we have 56 here. So we have the side length 56, and they're asking me for two things. I need to find the distance from A to C, and I need to find the distance across the riverbank, basically from A perpendicular to the other side. And for this particular problem, we are going to assume that these lines are parallel to each other. First things first, we can find out angle C really quick. Add those two angles together, subtract from 180, and we get a 55-degree angle. Why was that important? I couldn't use the law of sines at present what they had given me originally, because I had an A, a B, and a C. I did not have a match of angle and side length. And so now, once I've found angle C, I can use those in tandem, and I can work around the law of sines and find out a particular side. I need to find side length B, because it's across. The side length is always named by the angle that it's across from. So X is actually side length B. So we'll set it up like that. So let's see. We're going to say sine of 55 over 56 equals sine of 53 over B. Work that out. You find out that B is equal to 54.6 feet. So from point A to point C across the river is 54.6 feet. The next part, and this is a little challenging, they want you to find something that's not part of your original triangle. But the key fact here is you have parallel lines, and we have a perpendicular line that crosses the river. What we can do is I'm going to kind of take that triangle and redraw it so it's a little bit bigger so we can look at it. And so this is, we'll call this distance Y because it's not labeled. This is point A, this is point C. And what we do know is that X, or this part, is 54.6. 54.6. Now this is a right triangle, so this is kind of the stuff we've been doing. I need an angle before I can use sine, cosine, or tangent. If you remember, I told you that these lines are parallel, so all through these sides you have parallel angles. I do know that angle A, this part, is 72 degrees. So if you remember alternate interior angles, if this angle is 72, then so is that one. So we can use, this is opposite over my hypotenuse, and I can solve for a triangle. For part, let's write that up. So we're going to say sine of 72 equals Y over 54.6. So that's just sine of the angle equals the opposite side over the hypotenuse. Go ahead and work that out, and we find out that Y is actually equal to 51.9 feet. So not only do you have to be proficient in right triangles, I am going to expect that most of you know the right triangles. If you don't, then you're going to need a refresher. If you need this after school, or you can just pull out your notes and go through that, that might be a great idea. Let's see. That's going to be it for right now. We're going to look at something called the ambiguous case of sines. And that's probably the confusing part of this section. We're going to do that tomorrow. But part of your homework tonight is to watch a video tutorial on our website over the law of sines. I have a video of just the regular law of sines. I hope you watched that before coming into class today. If not, you can go watch it tonight. But there's also one that's a little more important that you need to watch on the ambiguous case. If you have enough time in class, you're more than welcome to get the iPads out and pull that out and watch those from there. If not, you can work on your homework. So here's homework. We're going to look at page 439. I could be off on that page. The book I have at home is a little bit different version. So what you want to look at is its section. We're at 5.5, and you want to do numbers. If you can't find section 5.5, ask your neighbor. They can help. Let's see. I want you to do 1 through 11 odd. A lot of that's just basically using the law of sines and finding the missing parts of your triangle. Spend the rest of the class period working on that. If you need, if you finish that up and you want to get the videos out or the iPads out and watch the videos, please do that. Take notes on the law of sines of the ambiguous case. That's what I want you to watch. Okay, so don't waste your class time. Make sure that you're working on something, and I will hopefully see you tomorrow.